So I'm Malavika and I'm here to present on the topic Flame Photometry, Atomization, Mechanism and Applications in Clinical Diagnostics. It is also called as flame emission spectroscopy. It is a qualitative and quantitative analytics, and it was developed by Richardson, John Berry, and Robert Hood. So the main use of this flame emission spectroscopy is that it can be used in inorganic chemical analysis to determine the concentration of certain metal ions like sodium, potassium, and lithium and calcium. So here is a pictorial representation of the uh, flame photometry. So when coming to the principle, it is based on the measurement of the emitted light intensity when a metal is introduced into the flame. And the wavelength of the color give us information about the amount of element present in the sample. This is particularly useful for analyzing the compounds of alkali and alkaline earth metals, which dissociate into atoms when introduced into the flame. So now let's look into the atomization mechanism. So it involves several key steps. First, the sample is introduced into the flame as a fine spray or an aerosol. Then the solvent evaporates and leaving some solid particles. It can be called as desolvation. And the third one is volatilization. In this, the solid particle vaporize and forming gaseous atoms. And the fourth one is the excitation step, in which the atoms absorb energy from the flame and get excited. And the last step is the emission step. The excited atom emits light at a specific wavelength as they return to their ground state. Moving on to the instrumentation, we have several critical components. The flame source that provide high temperature that needed for atomization and excitation, and the nebulizer that converts a sample into a fine aerosol, which is then mixed with the fuel and oxygen in the burner, creating a stable flame, and the monochromator selects a specific wavelength of interest, and the detector measures the intensity of the emitted light. As you can see from this diagram, the flame photometer consists of a burner, mixing chamber, atomizer, and a compressed air supply, then compressed fuel supply, uh, also lens, lid, filter, photodetector, amplifier, and LCD displays, etc. Each of these components plays a vital role in the accurate measurement of elemental concentration. When it comes to the application in clinical diagnosis, it can be mainly used to measure the concentration of electrolytes such as sodium, potassium, lithium in biological fluids like blood and urine. It also helps in diagnosing and monitoring various conditions such as electrolyte imbalance, which are crucial for maintaining proper physiological functions. Thank you.